21, according to the passage, the ability to detect DMS is useful to seabirds because. So here is where DMS is introduced. And it says, when those cells are damaged, the cells of algae, for example, when algae die or when marine grazers like krill eat it, DMSP breaks down, producing DMS. The smell of DMS alerts seabirds that food is nearby. Not the algae, but the krill that are consuming the algae. So krill, for example, start eating the algae. The breakdown of the algae releases DMS. The birds can smell DMS, which means they know, oh, there's krill nearby, because the krill is what they eat. So we look at our choices, and I like choice D. Signals to seabirds that populations of krill are nearby. Yep. C, like DMS does indicate that concentrations of algae are high, I suppose, or at least that they're being broken down, but that's not why it's useful to seabirds. The seabirds care about the krill. The algae, which is releasing the DMS, is sort of like the messenger, but what they care about is the krill. It's not about fog or plastic. This is not why DMS is useful to the birds. It's useful because it tells them that there's food. So 21D. 22, line 22, contained. The database blank information from over 20,000 birds. Okay, how about something like included or had, possessed, something like that. So we go to my choices, say included, looks good. Let's just check the rest. This database controlled information. It's sort of weird. Databases don't really control information. This database limited information. Doesn't sound too limited. This database accommodated information. No, this is not the right context to use a word like that. We can just say included. Plain word, but it works really well. So 22 is A. 23, 24. Can be inferred from the passage that prior to the studies conducted by the author and Nevitt, research on tube-nosed seabirds must have. So we're looking for information prior to the studies what research on tube-nosed seabirds must have identified. And we're looking between 41 and 56. And so as we read, we notice this. This is, I think, is this the only place where tube-nosed seabirds come up? I think in these lines, that's the only place where those words come up. 41 to 56. Yeah, so that, again, not proof of anything, but it's interesting that those words from the question, the keywords, appear in these lines. It says, we found levels of DMS that were higher than normal background concentrations in the environment and well above levels that tube-nosed seabirds can detect and use to find food. So wait a minute. They know then those levels. They already know what levels are required for tube-nosed seabirds to detect the DMS and to find food. That's something that they already had as a piece of information, which means that must have been something previously determined. And so when I look at my choices, I like A, the minimum DMS level that tube-nosed seabirds can smell. B, C don't have anything to do with tube-nosed seabirds, and D, it's not talking about the max amount of plastic that they can eat. So we get A for 23, and the lines that we used, which was 50 to 53, is going to be the answer for 24, choice C. 25, according to the author, the research he did with Nevitt is valuable because the results indicate that. So we want to see where the author discusses the research that he did with Nevitt and why it's valuable. So it's worth, its import. And so I notice right here, line 57, our findings have important implications. So here's where we're going to learn why it's important. So, or valuable. Our findings have important implications. First, they suggest that plastic debris may be a more insidious threat to marine life than we previously believed. If plastic looks and smells like food, it is more likely to be mistaken for prey than if it just looks like food. So, they have learned something, that this threat of plastic is worse than they thought. It's more harmful, insidious. So I go to my choices, and I like choice B. The scientific community may have underestimated the danger plastic poses to birds. We see that in those exact lines. A, it doesn't talk about seabirds recently acquiring this ability. I don't think it specifically says that the populations of surface nesting seabirds are declining. I mean, does it say that? Yeah, maybe they are, but it doesn't say that in any way. That's not mentioned as an important point. And doesn't talk about reversing the pollution. So 25 is B. 26. Which choice best supports the conclusion that a factor other than the presence of DMS can mislead seabirds into consuming plastic? So 60 to 74. What's another factor that can mislead them into consuming plastic? And it says in really, I think what we just read before in 60 to 62. So the DMS attracts seabirds because of the smell. And since the plastic has gets DMS on it, the birds smell the DMS and they go and they eat the plastic. So that's one problem. But the other problem that's mentioned in these lines is that plastic can look like food. So it can look like food and smell like food. So the added threat, the added reason why DMS can mislead, or why birds can eat plastic besides DMS, is the looks of the plastic. It resembles food. And so that's why our lines of evidence, choice A. 27. What is the point of the discussion of the burrow nesting seabirds? So basically they're saying in this paragraph that there are other birds, the burrow nesters, that are hard to count. So we don't really know what's going on with them. And this is a problem because these burrow nesters are more likely to eat plastic. So they're more likely to consume the plastic, and we have less visibility into their status, about their population numbers. So this is something we need to be very careful about. We need to redouble our effort, or double our efforts, to monitor them. And so we look at our choices. I like D, support a claim that certain types of seabirds, the burrow nesting seabirds, should be observed with more scrutiny. Yeah, we know they're more likely to eat the plastic. We don't have as much insight into what they're doing, into their numbers. So 27 is D. 28, line 71, surveyed. The difference matters because populations of hard to observe burrow nesting seabirds are more difficult to count than surface nesting species, so they're often not blanked as closely. So to me, instead of surveyed, I would kind of reuse this word here. If they're hard to observe, and so therefore they're not surveyed as closely, I might just say again, observed. I think observed here fits pretty well for surveyed. So I go to my choices here. I see judge, so it's not about observation. Polling, we're not polling the seabirds. That's silly. We're not exploring the seabirds, but tracking makes sense, right? If we go back to the passage, they are often not tracked as closely, right? That makes sense if you're trying to observe or monitor them. So therefore, best answer to this question is choice C. 29, which statement about the data presented in figure 1 is best supported by the passage? So let's just look at figure 1 first and see what we can eliminate, and then if we need to, go back to the text. So A, concentrations of DMS on the polypropylene debris would have been highest at the end of the 1 month period in both buoy locations. So they don't talk here about sort of the timeliness of this. Yes, it might make sense that a month later versus a week later or a day later, the concentrations would be the highest. But the figure itself has nothing to say about time. Nothing to say about, at what period during a month or whatever it's at its highest concentration. It's just not mentioned. It's not really mentioned in the passage either. And so I think for that reason I can get rid of A. B, surface nesting seabirds would likely have spent more time foraging near buoy location 2 than they would near buoy location 1. Well, to me, that seems wrong from what we read in the passage, because when I look at these numbers, the numbers on 1 are bigger than 2. And that means there's more DMS at 1 than 2. And if there's more DMS, it's stinkier, the birds will be more likely attracted to the higher concentrations of DMS. So if anything, B is the opposite. They would spend more time at 1 than at 2. The sulfur odor of the polypropylene debris at buoy location 1 would have been stronger than the sulfur odor of the low-density polyethylene debris at that location. Well, that's not true, because this number is smaller than 11.76. So the smell would actually be less for the propylene. How about D? DMS-sensitive seabirds foraging near buoy location 2 would have been more likely to seek out the polypropylene debris than the high density. So polypropylene, yes. Notice this number is big. Oh, wrong one. This number is way bigger than this number. And so that means there's more smelly stuff there, and they're going to be more attracted to where there's more smelly stuff. So D is accurate with what we see in the figure. The really only need for the passage we had for this question ultimately was this idea that the more DMS, the more attraction, the more the birds are going to be drawn to it. Once we have that, we couple it with the figure, and we see that it's got to be D. Number 30, figure 2. So we want to see the approximate mean percentage of seabirds found eating plastic debris that use DMS as a foraging cue. So here's DMS as a foraging cue. Here's the mean percentage of birds eating plastic debris. We want it to be yes. It's about 50% of the birds that do it. And so 30C. 31, which had the highest concentration of DMS. So let's go through the options here. So buoy location 1, high density polyethylene. Okay, so that's the leader right now. Buoy location 2, low density polyethylene. So that's this one. Nope, that is not bigger than 13. Buoy location 1, probably polypropylene. Yep, that one's winning right now. It's a bigger number. And buoy location 2, polypropylene. Wait. Oh, sorry. Buoy. Let's go back. So we already got rid of B. C is buoy location 1, polypropylene, which is here, which is not bigger than the 13.45. So we can get rid of C. But D is the 14.13, buoy location 2, polypropylene. So 14.13 is the biggest out of these four numbers. And so that means the answer to this one is going to have to be choice